Hello, class. So the first thing I want to say is I'm sorry about the audio in the past couple of videos. I hope this is a little bit better. I changed out headsets, so see how that goes. But today's video is going to be on chapter 1, or sorry, chapter 6, section 2, and this is going to be objective 1 of that section. So we have area of a sector. Okay, so what I've drawn here is a circle with two radii, a angle. Remember, this is called a central angle. And then we have this arc S. And this is the definition of a sector. You can think of it like just a slice of cake, right? It's just a portion of the circle, has two radii, one angle, and an arc. Okay, so before we talk about this area of this sector, let's go over what the area of a circle is. So the area of a circle, I'll just denote it C, so that way we remember that that's the area of the circle and not the sector. Area of the circle is just pi r squared, right? So pi r squared. Okay, now if we take part of that area out, right, it's just going to be a portion of this pi r squared. So, for example, let's look at theta equals pi over 4. Okay? Now, this theta is going to be some portion of the 2 pi that's in the total circle, right? If we rotate completely around, we go 2 pi around. So let's see what kind of portion pi over 4 is to 2 pi. So proportion, let's just write that out, proportion. So we have pi over 4 over 2 pi. So this is just saying how much have we taken out of the total cake, if you will. So whenever you divide with fractions, you multiply by the reciprocal. So we're technically multiplying by 1 over 2 pi. And that is going to tell us that the pi's cancel out and we have 1/8. So this is 1/8. So this is a total of 1/8 of our entire circle. That tells us that the area of the sector, I'll denote it as S, is going to be 1/8 times pi r squared. Now we can try to find a formula for a general theta, right? So if pi over 4 gives us 1/8 of the total area, we can look at just replacing this pi over 4 in this proportion with a theta. And what happens is we get area is equal to theta over 2 pi times pi r squared. The pi's cancel out and we're just left with area is equal to 1/2 theta times r squared. And that is going to be the area of a sector. Now I do want to note that we only did this for radians. So this formula right here is only going to work for radians. But let's look at one more example with a new angle and a new radius and see if we can find a number for the area of a sector. Okay, so what we have here is a new theta and an r, a radius. And all I've done is written down the area formula that we just derived. So let's do some plugging in and see what this kind of looks like in a real problem. So here we're going to keep this a. This is going to be equal to 1/2. Our theta is pi over 10. And our radius is 15 inches. An important step is to keep the inches while you're doing all of this work. So this is going to be squared, and you have to square the inches too. So this is going to be equal to pi over 20. I just multiplied the 2 and 10 together, and then I'm squaring the 15. So that's going to be 225 inches squared. 20 is 4 times 5. We can divide 225 by 5 and get 45. So then our total answer is going to be 45 pi over 4. And this is going to be inches squared. If you want to approximate that by putting it into your calculator, you'd get somewhere around 35.34 inches squared. And this is what it looks like to actually solve for an area of a sector. Now you might ask, well, what happens if I get some degree or some degree angle? How do I solve for this? Well, if you remember from sorry, I paused the video on accident. If you remember from last video, what we did was use the pi over 180 degrees proportion to change any measurement from degree to radian. So if you are given some angle 30 as your theta instead of pi over 10, then you just transfer that to radians by multiplying by pi over 180. You get some radian angle, and then you plug this in to area is equal to 1/2 theta r squared. Now this is an important step right here. You have to do this if you're given something in degrees. Otherwise, if you don't do this, then you have to change this formula because we derive this formula using radian angles. So that is important. But that is all for section 1. I'll have a video for section 2 up either later today or tomorrow. But I hope you guys enjoyed, and I'll see you next time.